Tello, and today's talk is about what is a genre, a graph unified model of categories, texts, and features. And I would like to start talking about elephants. These majestic creatures that appear in many sayings, in many fables. For example, this one about the blind man and the elephant. In this story, a group of blind men find for the first time in their life an elephant. So the different people here start touching a different part of the elephant and describe what they are touching. So some of them, they describe rather a rope or a snake or a spike or a tree. And so all of them mistrust what the others are describing because it has nothing to do with what they are feeling, what they are observing through their hands. I think this is a similar situation with genres and the different research fields. So because they are analyzing and they are focusing on different questions and different aspects of genre, the results are very different, and therefore there's little consensus about what genres in the different research areas are. In this case, in the case of genre, this situation, it's even worse because many of them, they are analyzing different literary traditions and different linguistic traditions, and they are expressing their results in different languages. So therefore, there is a double-blind situation. Many of the information is just ununderstandable for the others. However, we find every time that genres are being used both in academia and outside academia. For example, projects might define their scope in, for example, applying sentiment analysis for poetry. Therefore, they use this category of genre to define their own scope of analysis. But not only in academia, we find it also in libraries, in bookstores, or in streaming platforms. Today's talk is a report of my thesis, what I've been doing in the last 5 years, an interdisciplinary work between literary studies, linguistics, and digital humanities. And last year, I felt at some point that every chapter of my thesis, of my PhD, was a kind of a blind man. Each chapter was analyzing one very specific question about the genres, and the work wasn't giving an overview about that combines all these different results. So for this reason, I decided to write a discussion chapter combining the different observation in one abstract and computational model. And this is the summary of this discussion. So if you feel that I'm skipping some details, it's because I need to, because of the short format of this presentation. However, you find the code and the presentation in GitHub, and hopefully it will be published this year or probably next year. So, what traditions are on genre? The first and most classic one is the scholastic model based on this concept of genus proximum, for example, a person, and this differentia specifica, that is a male, adult, and unmarried. And this combination creates a category, bachelor. This is based on necessary and sufficient conditions, and it derives a taxonomy. So one specific item belongs to a category, and this category belongs to a more general category. However, in the 20th century, there has been different alternatives proposed. The first one is the family resemblance from Wittgenstein, where he rejected the idea that for many categories, you won't find necessary and sufficient conditions, but just a number of shared traits. Just as a family shares some traits, they don't appear in every member of the family, and even the members can share traits with all the families that they don't belong to. The second alternative is a prototype theory based on the work of Roche and the psychology, and the core idea is that some members are better representatives of a category than others. And this has been already applied to literary genres. Moreover, at least for the last 20 years, there has been several computational approaches to literary genres. So normally what is done is take text internal features such as frequencies of tokens, and we analyze it as a multi-label task. So we consider that a text can belong to more than one genre. We don't really analyze whether these labels with these genres, they are more similar to each other. So we consider just a flat structure, and there is always variance in the results. So some genres are much better classified than others. Now let me explain about the data sets I've been working with. The first one and the main one is the corpus that I have gathered for my PhD. It contains around 360 novels in Spanish. Everything is encoded in XML-TI. Something important about this corpus is that for each text, it has been gathered several labels about genre from several sources, and it has been annotated. Which kind of annotation? First, linguistic annotation. I consider linguistic annotation in this case TI tags, narrative characteristics of the sentence, grammatical annotation, semantic features from lexicographic sources such as WordNet or the dictionary Maria Moliner, and information about the entities. Moreover, I have manually annotated literary phenomena of each text, such as the narrator, information about the protagonist, the setting, or others, such as the type of ending. I have also worked with Théâtre Classique, a large corpus of classic French theatre plays, which I have analyzed with topic modeling, and also the books of the Bible and their traditional genres, such as historical books, prophetical books, and so on, which has been also manually annotated with information about the entities and the communication. Now let's assemble the graph, the model for genre. And for that, I'm following an inductive process from specific observations to a more general model, inspired with the sentence of Wittgenstein, to repeat, don't think, but look. The first observation is that a text can belong to any number of genres. This has been normally applied in this way from computational approaches when we use multi-label tasks. However, I think Santini's schema of 0 to n describes that in the best way. The second observation is that this participation on genres is not only in categorical ways. So some cases are better representatives of some categories. There are more typical cases, for example, of a historical novel than others. Now, this can be formalized as a bipartite graph. In bipartite graphs, we have two different sets of nodes. In this case, the green ones. You see here Medianoche, Zaracaín, and Paz en la Guerra. And another one with the purple, with the color purple, which are genres. So historical novel, war novel, adventure novel, and so on. So if one text has been labeled as one category, they are going to be connected with edges. But not only that, because some genres have been labeled by all the sources, such as this case. So in this text, the value of the edge, the weight of the edge, is in this case 100%, because all the sources have been labeled this text as a war novel. In contrast with other, the value, this value is not so strong in other cases, because only 1/3 of the sources has labeled this text as a historical novel. So in this way, we are formalizing the two previous observations. The third observation is that we can use internal features to classify categories, to classify genres. And this is an overview about the most useful features in general, for my case, for the classification. Now, these can be also formalized as a bipartite graph. In this case, the categories of genres, they stay in purple, 3, you see there, war, historical, and adventure novel. But now we have another one, blue nodes, which correspond to feature nodes. And these are the specific features of these categories. In my dissertation, I argue to use SID scores as a way of formalizing this specificity. So these are for example, enemy. The word enemy is a specific feature of war, or sovereign is a specific feature of historical. And this specificity, the SID score, is also expressed in the edge between the two nodes. The fourth observation is that no one using computational approaches is trying to find the necessary and sufficient conditions for a text to belong to a category. Rather, there is a much looser relation between features and the categories. So texts belonging to a category, they tend to share some features. However, we can find also texts that have particularities, even though they belong to a genre. So in this sense, texts behave similarly as members of a family in Wittgenstein's family resemblance model. Now we can see this when we observe that now the 3 sets of nodes, the texts, the categories, and the features, are combined in a tripartite graph, in which, for example, we find here that this text, Sonata de Otoño, it has been labeled as historical novel, but it shows one specific feature. For example, here is about vocabulary about telephone. And this feature is actually not typical of historical novel. It's actually typical of an adventure novel. So even though this text doesn't belong to adventure, it shares some traits with it. So in that sense, we are now observing the crisscross characteristics described in the family resemblance model by Wittgenstein. The next observation is that there is variance in the classification, and some genres are much better classified than others. So for example, here, this dialogue novel, it yields higher results in the classification than others. Now this can be explained now by the tripartite model, because we observe here that these 3 genres, they share more specific features. They are specific for the 3 of them. However, in contrast, the dialogue novel has many specific features, so that they are not shared with the other categories. So these are features that distinguish this category, this genre, both in the graph, and these are also the features that allow the classifier to differentiate this category better in contrast with the others. The sixth observation is that some genres relate to each other. Some genres, like naturalist and realist novels, they are more similar in comparison to, let's say, erotic novels or romantic novels. However, this intuition has lacked till now a proper formalization besides the taxonomies. Now, in the graph, we can observe that what we consider more similar genres, such as adventure, historical, and war novel, now they are closer to each other. And the ones that are more different, for example, dialogue, they are being pulled out by the other nodes that are not shared with the rest of the nodes. And now we can combine all the categories and add to them their text and features. And now we can observe how for the entire corpus, this has been the relationships are being displayed. So I consider this visual, this picture, I consider this a visual summary of the 400 pages PhD. And this could be the last slide of a DH presentation, but I think it is required to evaluate this model properly. Because networks and graphs are dangerous in the sense that they are very spectacular and they have this scientific charm. But for example, in the case of networks of literary characters, every time the researchers evaluate whether we really can find what we think, what information we expect in these networks, we are actually surprised by the results and how little of that it actually is there. So that's why I argue that before I start with interpretation, it needs to be evaluated. And for that, I run two hypotheses. First is about the centrality. So I expect the genres that have more distinctive features to be pulled out of the network, like the dialogue novel. So the genres yield very high. These are the genres that are better classified. So there's this hypothesis that the classification results should correlate negatively with the centrality in the network. I don't have the time in this presentation to give details about the classification setup and results. I have already published about that. This is a summary of the most important parameters and decisions, but the important thing is that at the end, for each genre, I obtain a F1 score, which is express how well the accuracy of the classification. And also for each subgenre, for each genre, I obtain an eigenvector centrality value. So some genres, for example, social or educational novel, they are more central in the graph in the sense of eigenvector centrality than others, such as erotic or dialogue novel. Now the question is whether these F1 scores they correlate negatively with the eigenvector centrality. And after a Pearson test, the results shows that there is a statistical strong negative correlation. So this supports the interpretation. The central genres in the graph are the genres that are hardly classified in the classification. So now we obtain a visual explanation of why some subgenres are better classified than others. The second hypothesis is about the similarity. Are similar genres really here closer to each other or not? And to answer that, first we have to ask ourselves, well, what do we consider similar and what do we consider to be close? For the closeness, I just use the proportion of shared features. So two categories that which share all the text and all the features would be 100% close. So the span of possible values is between 0 and 100. Similarity of genres is harder to formalize. And for now, I am considering close lists of genres that are typically treated together by scholars, such as historical, adventure and war novels, or realist and naturalist novels, or autobiographies, memoir and educational novels. And then I have observed whether these genres, this close list of genres, whether they are really closer in the graph. And the results show that they are. In all cases, they are among the 5 closest categories. In many of the cases, they are also the closest ones. And in other, what it happens is that we find less prototypical but still very similar categories. For example, we find between naturalist and realist novels, even though they are very close, even closer are social novel and literary fiction. So these two evaluations supports two specific interpretations. One is that the genres that are difficult to classify are in the center, measured through eigenvector centralities, and that similar genres are closer to each other, understanding closeness as shared nodes. This has been also evaluated in the other two datasets with very similar results. You find details in the Jupyter notebook. It has been done with the Théâtre Classique and with the books of the Bible. Conclusions. I'm running out of time, and I am aware that this model has several limitations. I'm working on it, but still I think that using graphs as a formalization for that, it also offers other possibilities that I haven't tried that could solve these limitations. Especially interesting is about the temporal graphs, for example. However, I think my contribution is a step forward in the discussion of literary genres, in the sense that it's an abstract and computational model for genre, which accommodates a series of observation of how features, categories, and texts interact with each other. It unifies several aspects of different theories, prototypes, family resemblance, and similarity and schema. It can be visualized and has been evaluated. The most important results of that is that first, it supports that it gives an explanation of this interaction of text categories and features, understanding them as expressing them as the centrality and giving them an explanation of why some genres are better classified than others. And it offers an exact quantification of the similarity of genres, especially when it is used with a combination of linguistic and literary metadata. This can be also used for empirical descriptions of genres. Which is something new, both in DH and traditional studies. I have applied it with real cases in several languages and different periods, and it opens further possibilities, such as, for example, calculating and creating taxonomies based on the communities of the nodes or the temporal graphs. So I am aware that there are sections of the genres of this elephant that I haven't really analyzed yet, but still now we have a better overview about the very complex phenomena of genre. Thank you for your attention, and wish me luck for my defense in September.